All right, so we are going to start with number 2. So for number 2, the very first thing that we do so that we can start solving for x is we cross multiply. So I'm going to do x minus 8 times x minus 4. So I'm going to write x minus 8 times x minus 4, and I suggest tomorrow on your test you write it out as well. Then we're going to do x times x minus 4. Sorry, x plus 4. Okay, so now on this one we have two things multiplied by two things. So what we're going to do is we're going to distribute one of the things in the first parentheses to both things in the second. So x times x gives me x squared. X times a negative 4 gives me a negative 4x. Then I have to take 8, since I already distributed x to both. We're going to take negative 8 and also distribute that to both. So negative 8 times x is negative 8x. Negative 8 times negative 4 is a positive 32. Then we distribute this x, so that gives us x squared. And then x times 4 is 4x. Now normally when we see an x squared, that usually means we factor, right? But since we have 1 on both sides, when we try to move 1 over, they both cancel. So we're not actually going to factor. That leaves me with negative 4x minus 8x, which is a negative 12x, plus 32 equals 4x. So from here, we want to get x by itself. So we add 12x to both sides. That gives us 16x equals 32. Then to get x, we divide by 16, and x equals 2. Okay? Everybody good with that one? Okay, just to make sure we know, corresponding angles in similar polygons, what are they? They're congruent, or you can think of them as being equal. So anytime you have angles, you set them equal. What about the sides? They are proportional. Very good. Which means that we are going to set two ratios equal. So I'm going to have a fraction set equal to a fraction. I cross multiply and I solve. All right. Next, we're going to look at 5 and 6. Okay, so for these quadrilaterals to be similar, they have to have the same angles. Okay, so we're going to start out and let's look at this angle here. So this angle has 3 marks, right? This one has 3 marks. This one has 3 marks. This one has 3 marks. And this one has 3 marks, right? Are they all in the same spot? See how this is the top corner of the small side? Is this the top corner of the small side? Top corner of the small side? Top corner of the small side? Top corner of the small side. So right now, all of them work. Okay? Next, we're going to look at 90. So we have a 90 here in the bottom of the small side. 90 here in the bottom of the small side. Do we have a 90 here? So we know it's not going to be C. We have a 90 in this bottom side and a 90 in this bottom side. Okay? Then we have 2 tick marks bottom of the long side. Are there 2 tick marks in the bottom of the long side here? Nope. 2 tick marks in the bottom of the long side here? No. But we have it here. Okay? So, if you have all 3 angle measures the same as all 3 in the other one, that means that fourth side, this side right here, would be the same as this one. So your answer should have been B. Yes. Are you talking about the answer that I had on the board? Okay, it changed to B, but it is B. Yes. I typed it in wrong. Okay. Now, in number 6, they want us to complete the similarity statement, which means that if we're completing it, we already know they're similar. So the order in which this one goes is they say A, B, C. So if I start at A and go to B, if I'm comparing the 3 sides, is this the short, long, or middle side? This is the long, right? Okay. So I went from A to B, and then from B to C. Okay. Is 12 the short or middle side? The short. Okay. So see the order we went? Long side to short side? So we're going to have to do the same thing here. So looking at these, which one is the long side? ZY. Which one is the short side? Oh, that should be yellow. Which one's the short side? XY. So if we went long side, short side, would we not have to start with Z, go to Y, then go to X? So it would have been F because we went Z to Y to X. Tomorrow I highly suggest that you bring your highlighters and things to help you keep those straight. Okay, the next one we want to look at okay, so these two are the ones that y'all don't have labeled on there. They're just, or numbered. They're just kind of there. So we're going to talk about these. So in the first one right here, they want to know which similarity postulate or theorem lets you conclude that triangle JKL is similar to triangle MNO. So our choices are either AAA, not AAA, sorry, AA or SSS. So in order to do AA, what do I need? 2 angles, okay? In order to do SSS, what do I need?
3 sides.
All 3 sides in both, right? So technically I need 6 sides, right? Do I have 6 sides? No, so immediately we know it can't be that one. Now, tell me the 2 angles, or tell me one of the angles that's the same. J and M, they both have the 2 tick marks. What other one? L and O. So those are 2 angles. Is that pretty simple? Did any of you already work that one? Okay. Now, 13 is a little bit more tricky. So they give you several more options. They give you AA, SAS, SSS, and then that they're not similar. So we know for AA, we have to have 2 angles. For SAS, how many sides do I have to have? 2 in each, so how many is that? 4. And then an angle. Okay? So do I have 4 sides? Nope, so that's not going to work. So does that mean SSS is going to work? Nope. So all it's between is AA and triangles not similar. Okay? So do we have 1 angle that's the same? Which one? Okay, this angle and this angle. Okay. Now, if we can find 1 more, we can prove they're similar. So does anybody have an idea? What do you think, Margot? Okay, good. So these lines right here are parallel. AB is parallel to CD. and then we actually have two transversals cutting them, right? We have this transversal right here, but we also have this transversal right here. So we're going to have to figure out which one to use. Okay? Now, originally, I circled this one right here, and I thought, okay, I can do alternate interior angles. Because alternate interior angles, and so I know that one alternate interior angle would be here, but then the other one would be here. Is that inside one of the triangles? No, so that didn't actually help me. So then I swapped to this transversal. Okay? Again, I cannot do alternate interior because one would be inside, one would be outside, but can anybody tell me, and I know it's been a while since you've done this, if I marked an angle here and an angle here, what relationship? Very good. They're corresponding. And what are corresponding angles?
Equal.
They're equal or congruent. So does that give me my second angle? Yes. Very good. No. There will be one like 14 on the test, okay? And so that's why I wanted to show you how to do it. Now, when it says explain why the triangles are similar and write a similarity statement, it's talking about choosing either angle, angle, side, 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 or side, angle, side. The way that you explain is you show these things, okay? So, how many, will side, side, side apply here? No, there's not enough sides. Okay? What about side, angle, side? Yes? Okay, well let's try side, angle, side. So to prove, we want to show a side, or two sides proportionate with the same ratio, and then one angle. So let's go ahead and do the angle, because the angle is always the easiest. What angle is the same here? L and M. So that's what you're going to write. That's how you show is angle M is congruent to angle L. So that took care of my angle. Okay? Next, we're going to look at the ratio of a side. So what side corresponds with 16? 12. Okay? So we would do 16 is to 12. Okay, and 16 over 12 when we compare them reduces to 4 over 3. Okay, so there's one side. Now I have to take the other side and make sure it matches. Okay, so I see that JM, see how, okay, I know somebody said when I said what does LK go with, we said the wrong thing. LK right here is in the same position as MN. So there should be no confusion because it gives you that up there. Now, for JM, we have 24. What goes with JM? JL. Okay? JM is 24. Okay? But what is JL? Because it's actually this whole length. Very good. We do 24 plus 8, so the whole thing would be 32. It didn't ask us for ML, which is 8. It asked us for JL. So remember, we compared 16 to 12, so that means we have to go 32 to 24. So if I put 32 over 24, what would that reduce to? 4/3. Okay? And so these match, right? So I have my side, and my angle. So that means I proved it by side, angle, side. Now, you have to also write the similarity statement. And what's so great about this, see how they already tell you the two triangles? All you do is copy that straight down exactly the way it is. Triangle JLK is similar to triangle JMN, and then you'd put by side, angle, side. So is that as bad as you thought it was going to be? No, you just have to show each little thing. And if you can't do that, then you're just being lazy. Yes? What's your question? Okay. You want to show, if it's angle, angle, you show the two angles. If it's side, 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 you show the three sides. And if it's side, angle, side, you show the angle and the two sides. Does that make sense? Because you will have problems like this tomorrow. Yes? Mm-mm. You have to explain, and explaining is showing. Okay, let's look at the next ones y'all had questions on. Okay, second number 5 was this 15, right? Okay, so in this one it says, a map is scaled so that 3.6 inches represent miles. So what two things are we comparing? Inches to miles. Very good. Okay, and so the first thing they tell me is 3.6 represents 9. So this is going to go with this. So we put 3.6 over 9. Then the next thing says 2 cities are 7 inches apart, and we want to know how many miles that is. And so anytime they say how many, that's the thing we let be x. So again, I have to do inches over miles. 7 is my inches. Miles is x. So from here, we just cross multiply, do 3.6 times x, which is 3.6x, and 7 times 9, which is 63. From there, to get x by itself, we divide by 3.6. And what does that give us for x? 17.5. Yes? Miles over inches? Yes, as long as you keep it consistent on both sides. Yes, you could do it that way. All right. Next one, we're looking at 24, which is my 23, I believe. Which one of these is 24 for y'all? 23? Okay, you're asking for 24. Tell me which one is 24. Okay, thank you. Okay, so on your copy, this is 24. Okay, is there a specific, like, x or y that we're not sure how to solve, or we want both of them? Okay, so what is y? Is y a side or an angle? An angle, okay, and so what do we know about angles, corresponding angles? They're equal. So we get y squared equals 25, okay? How do you, remember, all we want is y. So what is the opposite of something being squared? The square root. So to get rid of the square, we just take the square root of? I'm pretty sure, because I can't do plus or minus, I put 5 comma negative 5. Okay? And the last one you asked for was 28. So is 28 29?
Yes, ma'am.
Okay, and so this is the one that we kind of struggled with yesterday as well. So there is actually supposed to be, I don't know if there's an arrow on your copy, but there's supposed to be an arrow. So we notice that both of these lines are parallel. And then we also see that this middle line touches both sides. Okay? Now, 22 and 6, are those sides or the bottom? They're sides because the middle one's cutting the sides and this falls on the side. Now, anytime that you're given the measures below the parallel lines, these are considered the bottoms of the triangles. So when you're given sides and bottoms, you compare the side and the bottom in the small triangle to the side and the bottom in the big triangle. So let's look at the small triangle first. The small triangle is this one right here. So what is the side in the small triangle? 6. And what's the bottom? What? 8. Okay? Then we look at the big triangle. So what is the side in the big triangle? Okay. The side in this whole big triangle is 22. This little arrow thing, or this, means this whole length. I'm talking from this end, which is why it has this thing, to this end is 22. So the side is 22, and the bottom piece is x. I'm comparing the side to the bottom of the little triangle, and then the side to the bottom. Eight over x is what you did? Equals 6 over 22. That would be like comparing sides. Did you end up with the same answer as me?
I did too.
Okay. So that's because, remember yesterday when we didn't have the whole length and they were just giving us parts and we were trying to do part and then whole bottom and whole bottom? As long as you are making sure that you're using whole bottom and whole side, you can set it up 6 is to 22 as 8 is to 6, as 8 is to x, because x and 22 are the whole thing. Just don't get in the habit. Make sure you know that when you're only given a part right here that you have to find the whole, because it will work the way you set it up. Okay, so from here, this gives us, and when you cross multiplied, you would have got the same thing. 6x equals, what is 22 times 8? 176. So y'all see when you cross multiply, it ends up the same. Divide by 6, and x equals, is that right? 29.3. Okay, and so we don't have any more questions. What about the very last one? Do y'all know how to do that very last one? 32? Raise your hand if you did 32. Okay, and so all the other people who didn't do it probably would like to see how to do it, right? So flip to the back and let's look at 32. So in 32 it wants us to tell us which of the triangles are similar. Okay? And it gives me 3 triangles. It gives me Jkl, Pqr, and STO. So we're going to go ahead and plot Jkl. So I'd have to go -4, 6. And that would be J. Then we'd go 4, 6. That's K. And then we go 4, 4. Okay, then you would connect all of those. And to find that they're similar, I either have to do side, side, side. I have to do side, side, or I have to do angle, angle. So which one of those do you think we're going to do? Side, side, side. Okay, so let's go ahead and get the length of the side. Do you know how to easily find the length of this side from J to K? Count it. So we go over 1, 2, 3, 4, 5, 6, 7, 8. So the length of this side is 8. What is the length of this side? 2. Okay? Now, is it going to be the same finding it for JL? No, you cannot count when it's going across all of those. So what we're going to do is, it's been a long time since we used the distance formula. So I'm finding the distance from J to L. So I'm going to label. Distance is x2 minus x1. So 4 minus a negative 4 squared plus 4 minus 6 squared. So 4 minus a negative 4 is actually 4 plus 4. 4 plus 4 is 8, and 8 squared is 64. Plus 4 minus 6 is a negative 2. Negative 2 squared is 4. Or, yeah. So we add it and we get square root of 68. Okay. So I'm just going to leave that. Well, let's go ahead and get a decimal. What is the square root of 68? 8.25. Okay, yes. The farther out you go on this problem, the easier it is to compare. So if you have to round on the test, I'll tell you where to round it. Okay, now let's plot this one. So I have to go to negative 2, 3, put a point, and that is P. Then I have to go to 2, 3. That's Q. And then I have to go to 2, 2. And that's R. So connect all your dots. How long is P to Q? 4. How long is Q to R? 1. And then we need to find from P to R. So that's going to be 2 minus a negative 2, which is 4. 4 squared is 16. Plus 2 minus 3 is a negative 1. Negative 1 squared is 1. So that gives us square root of 17. And what is that decimal? 4 point what? Okay, and then the last one, we're going to plot S, T, and O. So S is negative 4, 1. T is 0, 1. And O is 0, 0. Okay, so how long is ST? 1, 2, 3, 4. How long is TO? 1. Okay, and then we want to find the distance from S to O. We don't know that it is a exactly a right triangle. Good. Okay, so from here we're doing -4 minus 0, which is -4. -4 squared is 16, plus 1 minus 0, which is 1. 1 squared is 1. So that is square root of 17, which would be 4.12. Now, take just a second to think about this before you answer. Is PQR similar to STO? No. What are they?
Congruent.
They're congruent. Okay? So let's see the side comparison of Jkl is, let's do 8 to 2. What is that ratio? 4 to 1. Okay? What about the same side ratio of PQR? So let's see if those are similar. So this would be 4 to 1. Are these two similar? Yes, those are the same. So that means triangle Jkl is similar to triangle PQR. Okay? Knowing that the ratio of the sides of Jkl is 4:1, what's the ratio of the sides of STO? 4/1. So that means that triangle Jkl is also similar to STO, but PQR is not similar to STO because they are actually congruent. Does that make sense? Okay.